All right, so let's take a look at section 10.6. Okay, first thing is I just want you guys to look at this. You don't have to write all this down. Okay, just listen to this as I read it. Okay, it says that Peter earns $20 an hour for playing in a band. So basically, if he works 1 hour, he makes $20. If he works 2 hours, he makes 40. What if he worked 3 hours? 60. Okay, there's a direct relationship between how many hours he plays and then how much money he makes. Okay? That's an example of direct variation. Okay? So this is, again, Mr. Roy doesn't have the notes for today, so you're going to be taking them on your own. All right? But this part, I just want you to watch. Okay? So, in that example, okay, the amount of money that Peter earns is directly related to how many hours that he works. Okay? Any question on that? So the more time that he works, the more money he makes. The less time that he works, the less money that he makes. Okay? This kind of situation can be modeled using this equation. Right? And I want to show you how we came up with that. The 20 is how much money he makes per hour. Okay? It's how much money he makes per hour. N is how many hours that he works. E, that's the earnings. Okay, so let's try the formula, see if it works. Let's say he works for 1 hour. So the number of hours he works is 1. What's 1 times 20? 20. 1 times 20, he'd earn $20. Okay? Let's say that he works for 2 hours. What's 2 times 20? 40? So he'd earn $40. Let's say he works for 5 hours. What's 5 times 20? 100. So yeah, he'd make $100. Okay? So this is an example of a formula that represents direct variation.
What's this called? Can you go up so I can see up to where this is variation?
So this is 10.6, direct variation. All right, so what I want you guys basically to get out of this page is what a direct variation equation looks like.
That's it. The only thing, as far as your notes go, the only thing you have to worry about running in right now is where it says 10.6. What's the title of this chapter or this section? Direct variation.
Okay. And a direct variation equation is always going to look like this. It's going to have a letter. It's going to be equals, then a number, and then another letter. Every time. That's what a direct variation equation looks like. Here's an example of another one. Y equals 2x. A letter, equals, a number, and then another letter. We'll use x and y a lot, because that's what we're used to when we do graphing. Okay? But this equation used E and N for expense, or earnings, and number of hours. Okay, so let's take a look. So direct variation. Okay, that previous example we just looked at was direct variation. So this part is important. Okay, direct variation. First of all, it's a straight line when you draw it. Okay, so if you were to make a graph of the hours and the money that Peter made in the band, you say for 1 hour he made 20, 2 hours he made 40, 3 hours he made 60. If you graph those points, they would be in a straight line. Direct variation is always in a straight line.
So yeah, so you see that people. I already see people start on the right. So people have already started on the right. We already have direct variation, and it says is. You're going to fill in everything after is. A linear function defined by an equation. You don't have to worry about of the form, because it's already on your guided notes. So direct variation is, and you have the blank. You're going to write in a linear function defined by an equation.
Is that a K or a?
That's a K.
That's a K.
Y equals KX. Now K can be anything you want. It can be a positive, it can be a negative. There's only one thing that K can't be. Anybody have a guess?
Equal.
0. Very good, yeah. K can't be 0. Yep, it can be a decimal, it can be a fraction, it can be anything except the number 0. And k has a special name. Okay, when you're doing direct variation, it's called the constant of variation.
So you guys have the little, see it as K on your guided notes, and there's like a little arrow and a line. What do you think you're gonna write on that line? Constant of variation, right?
And I want to get you guys kind of used to the way you're going to see some of the questions worded on the test. Okay, the wording that we're about to show you here, you're going to see this in the homework, you'll see it on the test, you'll see it on the review guide.
You giving us homework?
7 questions.
Yeah, 7 questions. Okay, guys.
Guys, focus.
Yeah. So the equation y equals kx. The way you can pronounce that is y varies directly with x. Sometimes they say as x. I like to say with x.
So what it says on your thing, guys, read as, you're gonna write in your quotes, y varies directly as x or with x.
Yeah, you could say it either way. I like to say y varies directly with x.
All right.
But either way. So for our earnings problem and the number of hours Peter worked, you could say the earnings Peter had varied directly with how many hours he worked. His earnings varied directly with the number of hours he worked. So what that means is more work, more money. Less work, less money.
Right, so on your thing, guys, where it says usually, you're gonna wanna write, usually plugging in x. You're gonna write, there's gonna be quite a bit in that line. You're gonna write, where it says usually, with that bullet, you're gonna write usually plugging in x. Or solving for y. Red as, right up there. Y varies directly with x. Where it says red as, you're going to write in y varies directly with x.
And for some of the problems in the homework, some of the problems on the test, you're going to be asked to find this, the constant of variation. Okay, that's, what letter was the constant of variation again? K. The constant K is the constant of variation. So if they ask you to find the constant of variation, they got to give you a little information to do that. Okay? Generally, what they're going to give you is a coordinate. What's another name for a coordinate?
Pair.
Yeah, what kind of pair? Coordinate pair, ordered pair, yeah. So they're going to give you an ordered pair. So they'll give you an x. They'll give you a y. You're just going to fill in the x and the y, and you're going to solve for k. This is going to be a very easy equation to solve. Okay, very, very easy. Everybody, does everyone have that step? So to find the constant of variation, fill in x, fill in y, solve for k.
Where do you put that?
Don't have to worry about writing that on there, guys.
Okay, but make sure you know how to do that. We're going to go through some
There's
examples.
a couple examples anyways.
Okay, so here's our first example. Y varies directly with x, as x, same thing. They tell you when y is 45, x is 9. Okay, ignore that second part for now. Let's just find the constant of variation. We'll worry about the second part after. What's the equation look like that we use?
What's he gonna use? What's that equation? We just talked about it.
Y equals.
Yep, y equals
KX.
kx. Okay, do they give me a value for y here?
Yes.
Yep, what is it? 45. Where's that going to get plugged in?
Where's the Y?
Where the y is. Good.
Guys, this is example 1A, which you do have on your notes.
Do they give me a value for x?
Yeah.
Yep, what is it? 9. Where's that going to go?
It's not already X's.
Okay, so that gets plugged in for x.
Yeah. Okay.
Okay, somebody tell me what's that going to look like once I fill in those numbers in those two spots?
45 equals K9.
45 equals k times, yep, 9. Now, how do you get k by itself?
By 9.
All these equations, they're just going to have one step to solve them.
Divided by 9.
Divide by 9.
You read that? You read it?
So what does that come out to? What's k?
5.
K equals how much?
5.
5. Okay. Any,
Now, Mr. Jacobs, talk about that second part.
any question on how we got k for 5? All right. So now we have our direct variation equation, which we can write
Set that up on our paper. How do we do it?
something like that.
Put this backwards, so we flip that.
So-
Y equals
Yeah, it's,
5.
so you go back.
So in our example, this number is a little different. It's 5, but it's going to look just like that.
So, Mr. Hager, just divided by 9. That could be, it's just written, like I think you just said, Tyler, it could be 9. The way we've seen it all year is 9K. All right? So Mr. Hager could have gone ahead and rewrote that 9K. All right? But then we just said the last step of an equation. Last step of an equation, most cases you're going to divide. That's why Mr. Hager divided. All right? That's how we got to 5. Now in your equation, the y equals kx, now you found k. You found out what it is, now you know.
So what do we put in the box on the line?
But that box has nothing to do with anything right now. We're on example number 1.
Yeah.
I use that box.
That box has nothing to do with anything.
We just listen?
Just listen, this is example number 1. So to the right of it, like Sam just did, she wrote out how to do it. She wrote down the steps that Mr. Hager did.
Okay. Now, the next thing I want you guys to do is take and fill in 5 for k and leave y and x the way they were. So if I do that, what will my equation be? Leave y and x as letters. Just
It's going to be 35.
y equals 5x. Good. This is your direct variation equation. Hey, if you're not sure, just watch it, and we're going to do some examples. Okay? Okay. So y equals 5x is your direct variation equation. Any question how we got that? We found k, and then you fill it in using the steps right there. Now the last part. What does that last part say to do? Find y when x is 7. Now if you didn't know k, you couldn't do that. But we already found k. We have our equation. So how are you going to find y when x is 7? How do you know how to multiply? What are you going to do with the 7?
Well, because you bring it down to the other x.
You're going to plug it in.
Yeah.
Okay? So now you can find y.
35.
Yep, y equals 5 times 7. Or y equals 35.
So that one was 2 steps. First, you had to find k, find the constant of variation, and then solve for y. So you gotta read and ask, just gotta see what it's asking for.
Yep. Okay, try another one very similar. It says y varies directly with x.
Guys, 1B is not on your sheet,
Where is it?
on the board.
Oh.
You don't have to. Just watch.
Okay, what's my first step? What do I need before I can even start this problem? I have nothing right now.
Formula.
I need the formula. Good. What's the formula?
Y equals KX.
Y equals kx. Now, what letter do you really need to find in that formula?
Okay.
Yep. Well, do they?
Guys, what do we find? What do we have to find? What do we have to, exactly, good, Caleb. We gotta find K first.
There's no K for K.
They give us a y. Okay, we already know y is 18. X is 27. So they give us a y, they give us an x. You got to find k.
So write that down.
Okay, what's the value for y here? Somebody help me out. What's the value for y? Yeah. 18. What's the value for k?
K.
K, we don't know. Good. Very good. What's the value for x?
27.
How do we solve for k?
You divide.
Divide by what?
27.
Good.
I don't know what that is.
Okay, the answer might come out to a fraction. If it does, we'll just leave it.
Can you guess? Can Mr. Hager, that 18 over 27? Can Mr. Hager reduce that?
Yes.
Yes, we can.
Somebody raise their hand and tell me, Marcus, what number is he gonna divide by?
9.
9. Okay. What's he gonna get?
2/3.
2/3. Good.
Okay. Any question on how we got k? Now, what do we do with the k now that we have it? What do we do with that k now that we have it?
Tyler, what's Mr. Hager gonna do next? Just like we did the last one. All we're using is different numbers.
And fractions.
And a fraction. That's okay. Don't worry about solving it right now. Just worry about setting it up.
We need this.
What's he gonna, in your equation, remember, going back to that equation again. What's the first thing in that equation?
Wait, that one or the
The
previous?
direct variation formula.
I don't know.
It says right on your notes, direct variation formula.
Yeah, but this doesn't even.
Direct variation formula. You're not gonna get out of this one. It says it right on your notes.
KX.
You see it? There you go, right? Y equals KX. It's giving you Y, right, Tyler? What's Y? Look on the top of the board there.
Well, now we're going to leave the x and the y there.
Yeah, we'll leave the X and the Y there, so just Y, correct? What did we just get, Tyler?
8.
What did we just get? K, right? What's K?
Letter.
No, what's K? We just solved for it.
Oh, 2/3.
2/3. And then somebody tell me the last part of that formula or that equation is what? Y equals K X.
Okay, so in your final answer, you leave the y and the x there. You just fill in what you found for k. Once you do that part, now we can answer this question. Find x when y is 8. Okay. When what's 8? Y is 8. So what are we going to do with that 8? Plug it in for y. Now we got to solve for x. What's our trick when you have a fraction in front of a letter?
What do you have to do?
What do you do on both sides?
Turn the 8 into the fraction.
I just, on the other side, on that right-hand side, guys, I just want it to be X. So what do?
Get rid of the fraction.
There's a trick. We multiply by something.
2/3.
Yes. Multiply by 3 over 2.
Multiply by 3 over 2. Good.
Anybody know what that's called? Reciprocal, good. Multiply both sides by the reciprocal.
And what happens when you do that on the right? They cancel out.
And then you put 8 over 1.
Yep, you can put the 8 over 1. You can reduce first or you can reduce later.
Reduce first. It's not reduce first. It's easier.
Over
Okay.
2.
How many times does 2 go into 8?
Oh no, 4.
Oh.
4 times.
If we're going to reduce first, 2
2 and
goes
the
into 8.
2 and the 2, how many times?
Once.
Once. 2 and the 8?
4.
4. Good.
Uh,
What do we get, guys?
12.
12.
12.
Wow.
Okay. So we found k. found our direct variation equation,
Yeah.
and then answered what they wanted. Okay. Any question on that?
That can be.
All right, so sometimes what they're going to do is instead of asking you to do exactly what we did before, they're going to give you some ordered pairs. They're going to give you some coordinates, and they're going to say, simple yes or no. Does this represent direct variation?
No.
Okay? And I'm going to give you a trick on how you figure out if something is direct variation. If you take y and divide by x, and it comes out the same every single time, that's direct variation.
So guys, that on that next part, the guys are asking about the box. You're gonna put y over x equals constant. So y over x, and in the box, you're gonna write constant. So just like it says on top, when given a table, all right, this is what you're gonna use. The y coordinate divided by the x coordinate. If it comes out the same every time, then you have direct variation.
And you'll probably have to check that for maybe up to 3 coordinates.
Yeah, I'm not gonna make you do any more than that.
So you'll have to check y divided by x 3 times. If it comes out the same every time,
You got it.
you're good. Okay, everybody got that? All right, so let's look at an example. Here's a table of data. It says from the table, I want you to determine if y varies directly with x. In other words, is this direct variation? Okay. Yes or no?
Yeah. Yes.
Okay. If it is direct variation, I want you to tell me what the constant is. Okay. How do you get the constant? Well, it's that number you're going to get every time, y divided by x. Let's check it for the first one. Okay. In that first row, what's y?
12, wait, wait.
Negative 12 divided by what's x? What is that? Negative 6. So now if we check y divided by x every time, what does it have to come out to?
6.
Negative 6. If it doesn't, then this is not direct variation. Okay, what's my calculation for the next row?
Guys, 2A is on your reference, on your notes.
Over 5. What's negative 30 divided by 5? Negative 6. Okay, so far so good. Let's check it one more time. What's my calculation in the third row? 12 divided by negative 2. What does that come out to? Negative 6.
Oh, that's really
Is that direct variation?
Yes.
So yeah, that's yes.
I get it now.
This is direct variation.
I don't understand where I got this -6.
Now the question is, what's the constant? What did you get every time? Constant is negative 6. If you were doing this problem out as an equation, that negative 6 would be your k. That's the constant. Okay? Any question on that? Okay, so it's pretty straightforward. It's not that bad. Okay? Let's try this one. Okay, let's check if it's direct variation.
No.
No. So,
Okay, what's my calculation in the first row? Yep,
36, 6.
36 divided by 6. Okay.
6.
What does that come out to?
6.
6. So now what are we hoping for it to come out to each time? It's got to come out to 6.
I think we'll go with 6.
No.
What's 64 divided by 8?
8. No.
Do I even need to check the third row?
No.
No. This is not direct variation.
Hello.
Okay, the reason it's not direct variation, it didn't come out the same every time like the last one. So what's the constant of variation here? There isn't one. It has to come out the same every time. This one didn't. Okay, so nothing we can do there. Okay, here's the same kind of problem, except instead of as a table, They just wrote the coordinates horizontally.
Oh, I just have a question. Oh, wait.
So, okay, so just, yeah, you can just watch this one. What would be my calculation to check the first one? What goes on top when we divide?
-3. -3.
Is it x over y or y over x?
X over Y.
Y over x. So what's y here?
5.
Okay, what's x?
-3.
-3.
-3.
Okay, now you can't reduce that, so don't worry about that one. Okay, let's check the next one. What's my calculation here?
-10 over 6.
That does reduce. What's the top and bottom both divisible by? 2. What's -10 divided by 2? What's 6 divided by 2?
3.
Are those the same number?
Yes. No. Yes. No.
Yeah. Okay, when you have a positive divided by a negative, those are the same number. Okay, let's check our third one. What's y here?
25 over
The constant.
Over -15.
It's a constant.
What's the top and bottom divisible by there?
5.
Both divisible by 5. How many times does 5 go into 25?
5 times.
How about into -15?
-3 times.
-3 times. Did they all come out the same?
Yes.
Yep, so that's direct variation. What's the constant?
Constant is -5/3.
Good, the constant is -5/3. Okay? Any question on how we figured out that that's direct variation or that that's the constant? Okay. All right, so the last thing we're going to do, and then we'll be done. We get 2 examples left. We're going to look at a couple word problems. All right, so
All right, guys, come on, we're almost done with the notes. Okay, turn around. Thank you. Joey,
okay, so we're going to look at some very simple word problems. Okay. Okay, the kind of problems we're going to look at are going to involve proportions.
guys, so listen to me. For that blank on the back side, now it says blank can also be used to solve word problems with direct variation. Write proportions.
How do you spell that?
P-R-O-T-I-O-N-S.
Spell it right.
Turn on the board for you, Isaiah.
Yeah, I want to get that in a second. All right, then on your thing it says something like this, guys. Then you have something that looks like this, right, on your notes. Kind of looks like that, right? We've done proportions before. You're gonna do. Oh. All right, so guys, I know she sneezed like 900 times. Oh my God. All right, we're gonna do unit 1 over unit 2 on one side of your proportion, and then unit 1 over unit 2 on the other side. One unit. Give me an example of like something we use in units to measure. Huh?
Meters.
Huh? Meters. What else? Inches. Miles per hour. Centimeters. Whatever. But make sure, guys, come back to me. Thank you. Guys, if you're going to use miles per hour here, you're going to use miles per hour here. If you're going to use weight here, you're going to use weight here. All right? They're going to match up on either side. Then, like it says, what does it say? How would you solve that? What does it say on your notes? You're going to cross multiply, right? You do this times this times this. Guys, one of these, listen, one of these will be an unknown. One of those will be, whatever you want to put as the unknown, X, Y, A, doesn't matter. One will be a variable. I don't care what, based on what, like Mr. Hager is going to show you one now, that you'll be able to figure out. So let's look at the next example. All right, so again, the distance d to the plane travels varies directly with time it has been traveling. All right, so if a plane travels 2,600 miles in 4 hours, how far does it travel in 6 hours?
And I want you guys to understand that you can only use a proportion
Does it increase speed?
because the problem
Listen,
says
guys.
varies directly. If you have a situation that's not direct variation, none of what we're learning today applies to it. Everything we do today, though, is direct variation. Okay?
So Ben, in that problem, what are my 2 units? No, how am I measuring whatever's getting mentioned in the problem? All right, one will be, I'm going to put miles first. Is that okay, Ben? This is the first thing mentioned. One is miles, the other is hours. All right, so I'm going to set up. What's the, Elijah, what's the first thing that it gives me in the problem?
Like the numbers?
Yeah, what's the first number it gives me?
2,600.
All right, 2,600. I want to put that on top, right? That's miles, right?
Yeah.
So we're doing miles over hours. 2,600 should go over what, Elijah? 4. 2,600 miles in 4 hours. All right, so I have miles and I have hours. Miles and hours. For my next one, right? How far does it travel in 6 hours? What's my mile? Who can tell me by raising their hand? Joe, what are my miles going to be?
2,600.
Well, that's for 4 hours. It's asking about 6 hours now. Well, I get based on setting it up, Dominic. X. We don't know, right? We don't know how far it goes in 6 hours. What's going to go on the bottom, guys?
6.
Just 6. What's our next step? Cross multiply, right? 4 times x, 4x. Then we got 2,600 times 6.
Oh, it's completely wrong.
Anybody got a calculator hand? What do you got, Kayla?
15,600.
15,600. Now, guys,
No, there's,
Wyatt, what am I gonna do? What am I gonna do now?
Divide by 4.
Wyatt, thank you, Wyatt. I didn't know over the weekend your name changed.
Yeah.
Why in the last 30 seconds?
I got
Wyatt, and Wyatt only. What am I gonna do? Divide by 4. Kayla, help us out. X equals what? On your calculator.
we have to divide by 4.
Yep.
3,900.
3,900. And that is my final answer. Make sure you label miles. 3,900 miles. All right? Everybody with me? Next one. The number of parts a machine can make varies directly with how long it has been running. All right? The machine can make 1,275 parts in 2 hours. How many can it make in 7 hours? Take 30 seconds, because you have this example on your sheet. Take 30 seconds. Don't worry about solving it right now. Mr. Hager and I just want to walk around and make sure you're setting it up correctly. Just worry about setting it up. Just like we did. If you're not sure, look at the last one. That's the big thing. Look at the last one. Look how we set up the last one. Guys ready?
Yeah, sure.
equal in there.
Oh my God.
Lesson.
Thank you. All right, so Our two units, one unit was
125 parts.
parts, right? Parts over what?
Hours.
Hours. All right, so, guys, calm down. My first parts. Oh.
Mr. Roy, you need to understand, I'm Isaiah, he's Eli.
No, Marcus called me Isaiah.
All right, so we got parts. What's gonna go here, Ben? What's gonna go here for parts? 1275, right? Underneath 1275, gonna be what, Laura? 2. Justin, my parts on the other side, it's gonna be what? Good man. Over what?
7.
Look at you going above and beyond, giving me more info than I needed. I won't tell anybody, Justin, that you're a math whiz. All right? Nobody needs to know. Just remember, when you make it in the big time in NASCAR, hey, when you make it in the big time in NASCAR, you're beating Jimmy Johnson. Fork some of that dough over to Mr. Roy. All right? So, here we go. Dominic. So you look like an easy candidate. This times this, what do I get? Guys, if you're going to talk on the side, I'll hold you after the bell. I don't care. Thank you. This times this, 2x. On the other side will be what? 89 what? 8,925. Everybody agree?
Yes.
Everybody agree? My friend Victoria in the back. What am I going to do now? She's like, damn, Mr. I thought I had it. What do I do now?
Do you divide?
Bye. Thank you. Victoria, finishing off for us. What do you get? She doesn't know. Okay, who had a calculator and did it? Spencer.
4,462.5.
4,462. Point what?
4,462.5.
Awesome.
I got a point
Why did you say that?
There you go. Final answer. Good.
I said 0.5.
I said 0.52.
You want a cookie?
I said 0.5 a minute ago.
Oh, okay. Sorry. Guys, take out a scrap piece of paper.
All right, so since your quiz this week is only going to be
Guys,
on,
listen what Mr. Hager's talking. There's nothing needed for that.
the quiz this week is only going to be on one section. Okay, so the homework tonight is going to be a worksheet. Okay, Mr. Roy, that I already passed out. That worksheet I passed out at the beginning of class, that is your homework.
This is a homework?
You have to pause it.